Okay, for those who have a Victron system and they want to use the remote VEConfigure, you can download the VEConfigure for Windows only, but you'll be required to purchase the MK3 unit. My option is to download Victron Connect, which would be this. Okay, and we'll go online, view, and then go to device list and scroll down. Now my system is off right now, otherwise if I was to hit this remote VEConfig, it'll give me the option to download the settings, make the changes, and uploading it. So simple as that. In either scenario, you need internet, some sort of connection. When my unit is parked outside, it has access to my internet, or you can do a hotspot. And it eliminates the need for me to buy the MK3, even carry a laptop, because I could do this via iPhone or iPad, not necessarily just the computer. And I can create and save these configuration files and put it in my iCloud. And if I want to make changes, which I do sometimes, I just simply, on a Mac device, upload it and it changes the settings, as long as I have internet connection. It works great. I believe I may have had videos previously explaining how it's done. I'll have to look to be sure I didn't delete it, but if you're interested in how that's done, just let me know, and if you cannot find that video. So this is all I use. Why waste $80, $100, depending where you buy it, when it's something you may only use once in a while, and you can do the same thing. I know some sellers are trying to push you to buy these, saying, oh, it's more reliable, but I can't see that. You can also connect your laptop to Ethernet cable, as long as you have internet. So the Turbo GX supports Wi-Fi, Bluetooth, and Ethernet. Okay. I just save the configuration files in the downloads. I mean, same thing, yeah. This is it right here. I open it. It'll launch a program. Okay, let me zoom in on this. So this is how it looks. It's important that the settings, of course, be done right. Otherwise, your system may not work properly. You can cause damage to your battery or even to your devices that you're providing power. First thing, of course, you need to know is your grid power system. In North America, it's basically system frequency is 60 hertz. Europe, other countries, is 50. In my case, it's 60 hertz, so I have set it. Shore limit. I'm using a MultiPlus, and it's 30 amp service up to 50 amps if I use a secondary option there for AC out number 2. By default, I set it for 14 because most of the time I am off grid and running 14, running the Honda 2000. I could put 15, but I just put 14. And I've also set up for overruled by remote, which will allow me to use my Victron Connect, or when I'm connected to my system using the Turbo GX, I have the option of changing that 14 into steps that's listed, or in increments of 1 amp each time. Shown here, but if you have a unit like a Quadra, the AC input current limit, you would have two options because it's 240, 120, 240. And it also provides AC out 1, AC out 2. But with the MultiPlus, there's only one. So only one change. There is a 10 amp AC out 2, which is only active when you're on grid. So it's not a concern. The next item is dynamic current limiter. It's important to have this on if you're using, for example, a generator. It will control the current surge by delaying, giving the generator time to meet the demand. But if you're not using a generator, you could untick this setting. I think by default, it would not hurt to just leave it on. Now, next step is enable battery monitor. For other settings in the inverter, it's important that this is turned on. We'll talk about it when we get there. In my case, I am using lithium, Sunfun kit, 300 HP. The plan is to get a few more, but I've been testing this with different batteries like SOK 206. I even have 3 100 amp lithium batteries, some Chinese brand. And I put all of them on at one time to see how everything worked. And I was surprised how the charging and discharging was very consistent. Just using the BMS, not the BMS, but the Victron Turbo GX and its settings. State of a charge when bulk is finished. Depending on the battery and the make, it can be anywhere between 90 and 95%. In my case, 95% would be the minimum, where it will be about 95% charge, maybe even 90 on some of the other batteries. Once it reaches that percentage, of course, it will go to absorption. Now your battery capacity, most of the time I'm using the Sunfun kit and SOK 206, so it's about 506 amp hour. Just testing how it all behaves. Now the efficiency right now is set for 1, but it should be 0.99. There we go. Again, check your manufacturer. Some batteries will say 96, some will say 98. And my batteries are new, so it should be quite efficient. After several years of use, that may change. This is important for the system to accurately determine how long it's going to take to charge your battery. It usually gives you a time period. If that's not set correctly, it won't be as accurate. That's the only concern about it. Now there's a hidden setting, especially when you first set up a battery and it's brand new. Let's say it comes with a 30% state of charge. If you do a right click, change state of charge, hit that. By default, it's 0. But let's say this battery has a state of charge of 30%. Put it down to 20, always much lower, and hit OK. This way, it will prevent your system from thinking that the battery is 90% or 100% starting. And if it thinks, for example, that it's 90%, but it in fact is only 30%, it will stop charging at 90% initially. So this will force the system to determine through the voltage reading what the actual state of charge is. I've always left it at 0% regardless of what batteries I have, and after 1 or 2 cycles, It seems to work, but that's an option. Okay, so this is the general. Next one we'll do is the grid. Country, grid code, standard. If you're off grid, leave it. It's not applicable. You have to, for example, have this system in a house or some sort of building where you're providing power to your electrical power company. With this system, well, MultiPlus, it's not a system that you would necessarily use. You could, but it's certainly not worth it. And today with some of the grid companies actually charging you for storing power because they feel that they're losing some money. Who knows? It's something that, if you go on YouTube, it seems to be an issue for some people where they have so much power to give to the grid that they're actually doing a countercharge. Discouraging, of course, providing grid power. Okay, let's go to the next favorite feature is the transfer switch. The advantage of the transfer switch allows for uninterrupted power supply. If, for example, you're plugged into a short power, the breaker trips, it will immediately switch to power it through your battery system, and will go back to short power when the short power is restored. So if you're in the middle of using something electrical and the short power is lost, well, you can keep on using it. So it's a nice feature. It's the main reason why I got it. There's another reason, but this is one. Now, the next part, which is very critical, AC low disconnect, AC high connect, and AC low connect, and AC high disconnect. This is quite critical. Let's say you are on an offshore short power system, maybe a little bit archaic, or the local area, they're having some sort of voltage problems. By default, if the voltage, let's say your normal voltage is 120 volts, which is, in my case, the way it's set up right now, if it drops to 90 volts, only then will it disconnect and then operate off your battery system. 90 volts is very low voltage. Be very hard on compressors, pumps, things of that sort. So you need to change that. And then you need to tell it when to reconnect. And also, there's the other extreme. Let's say your voltage normally is 120 and you hit 140 volts AC, only then it will disconnect. That's high voltage. It could cause damage to windings, things of the sort, motors. So you need to set this according to what your normal voltage is. In my case, it's 120. And the sum of rules, if you want to call it, set it 10%. So if the voltage drops 10%, it should shut down. So what would be 10%? Of 120 volts would be 12 volts. So you subtract 12 volts from 120, that will give you 108. So 108. So if the voltage drops from 120 to 108, it will disconnect. If you have some real sensitive equipment to voltage, you may be providing power to a lot of electronics only, then you probably want to reduce it to 5%, which would be roughly 6 volts. That would be about 114. But in my scenario, I really don't have that type of sensitive equipment. All my sensitive equipment have protection against a wide range of voltages, so not to worry. So 10% is what I'm going to stick to in this case. Now we have the AC low connect. I need to tell it when to switch back to shore power. Let's say the voltage, it dropped to 108 or lower, and it's sensing, and then it notices, okay, the voltage is climbing, 114, 115. So at 5%, that would be 114. So at 114, when I was experiencing a low voltage, the transfer switch will switch back on the short power. Now let's look at our AC high. Well, let's go to high C, high disconnect first. Normally 120 volts, and for some reason the voltage spikes to 140, the system will shut down. 140 is a little bit too high for me, and it doesn't follow the 10% rule. So in that case, the high disconnect should be 132 volts. Okay, it was over 140. It has sense that the voltage has dropped down to 120 something. When do we tell it to use the off-grid? Again, we use the 5% rule, which is in my case 6 volts. So that will be 126. There you go. Again, you can use 5% on everything, depending on how critical equipment you're operating. But for a normal RV use, you're running a coffee machine or hot plate or something of that sort, that wouldn't be a concern. And most electronics these days are running off 5 volts DC, things of that sort. If you're running motors and compressors and stuff like that, then, or even some of the old style TVs, the old tube TVs, if you happen to be using that, yeah, it will fail at those low voltages. Okay, the UPS function. In my case, I leave it fixed all the time. Enabling this feature provides protection against frequency distortion, your AC frequency distortion waves. Turning it off will allow for more power surge, such as for motors. From my experience, there was no issue with turning on, for example, my air conditioning units in the trailer with initial surge. So my feeling is wave distortion could cause more damage than a bit of inconvenience of surge. And the system handles it quite well. I don't need excessive amount protection of surge. So I use a UPS at all times. Let's go to inverter. Okay, the normal electrical voltage here is about 120 volts. If you're in Europe, it'll be 230, 240. Maybe in some places it'll be 110. So that's where you would enter the 120 volts. And of course, your Victron has to be a 120 volt version, not a 230. Otherwise, it won't work if you're on a 120 grid, short power, and you have a 230. So it's important to select the right unit. In my case, this is a MultiPlus 1 for an RV, about 30-footer. I got the 12 volt system. I have yet to see need for 48. 48 volt systems are getting cheaper, but at the time that I started this, they weren't. and they were scarce. And there was a lot of issues with a lot of the offshore that I didn't want to touch. That's why I went Victron, and I could have went to 48 with Victron, which was suggested to me. But as I explained, I don't have a need, because the way I'm designing it, it's just to provide power from my battery system or my AC to feed my converter in the trailer. I'm not upgrading or replacing the converter or replacing all the wiring circuit. So perhaps in another project, I may look at it if I find that I'm going to be running a lot of heavy equipment. But I could run my Nespresso coffee machine, no problem, cook on a top such as an induction top cooker, no problem. Even run the air conditioning. I found the average, if I was running a lot of heavy equipment like cooking and air conditioning off and on, I would run my 2000 watt Honda generator, and it will provide the power to run all those other things. Just the initial surge you wouldn't be able to, so it uses the battery. And after that, it's providing power to the devices, plus charging my battery at, it may charge at a much lower level, not 120 amps, for example. It may only do 5 amps or 10 amps, depending on what the load is. And generally, after 1 hour, my battery is back up to normal levels once I finish using the heavy devices. The air conditioning is the only one that you could end up using it all day, and that would be a problem. But what I found is I just run the fan, and you're less likely to use your generator as often. Or assist, I got selected. This is great, especially when I fire up air conditioning, and my Honda, of course, can't handle the surge. It will kick in the system, provide the power using the battery system, and it gives it a little bit of time for my generator to pick up speed or to handle the surge. So no strain on my generator. Good way for your generator to last a long time. Ground relay, that is something you want on all the time. There's only a couple of cases where you wouldn't. It's a safety feature. It prevents ground loop. All fault currents are directed towards Earth. It protects you against electrical shocks. When off-grid, the neutral is grounded. When you're on-grid, it is ungrounded, and your offshore power should provide that protection. The Victron system will switch automatically. The only time you would use this, in other words, turn it off, perhaps when you're using 240 volt appliances, such as a MultiPlus 2. Okay. It can kind of cause you problems with the L2 lines, apparently. It's a scenario that would kind of vary depending how things are wired up, I guess. But if possible, best to use the ground enabled. Now, if you have a alternate grounding system or for testing, then you may require disabling the ground relay to do DC input for shutdown. Now, this is using voltage as settings, and while the other side is for state of charge. This would work great for lithium, not for lithium, but for lead acid batteries. It will work kind of with the lithium, but not as accurate or reliable. In my scenario, even though I am using lithium, I have both of these enabled. and that basically is required anyways. But it gives you the state of charge option. So DC input for shutdown. Again, check your manufacturer battery. Some will say 10, some will say 10.2, but generally speaking, I think mostly it's 10.8. That's what I use. If and when the battery does drop to 10.8 and my state of charge is down at 10%, then it will shut down the system. This will protect it from killing your battery completely. It could shorten the life and cycle of your battery, whether it be lead or lithium. And you don't want to start using it when it's just starting to charge. Give it time to charge up a little bit. So basically for DC load restart, I have it set at 12.4 volts. So once it reaches to 12.4 volts, then the system will activate and using it. Of course, you want to keep your load level low or have your system set up so that your offshore can handle both the charging and whatever load you're running. I had one occasion here about DC input low pre-alarm. When I upgraded my Sunfun kit 300 HP to a new system, which I will show in a video, which I just love right now. But anyways, I had settings that I forgot to change, and I was getting low voltage alarm. And every time I checked, no, everything's good. Obviously, my DC input low pre-alarm was incorrect. And the reason why you want to set this at 12.4, it gives you time, it gives you warning. You get a beep. If you have VRM email notifications set up, you get a email saying that you're heading towards low voltage. So you can get up, switch battery source, or hook up your generator. You don't want to be in a scenario where suddenly your battery is dead. You had no warning, and in the dark, you got to dig out your generator or find another source. I have shut down on state of charge. I have it set for, starting to dim there on my laptop. I have it set for 10%. Some will say, no, you need to set it at 20 because it would extend the life of your battery and so forth. I think it's more of a cellular desire. At 10%, I really don't believe it's going to reduce your life of your battery. It's only when you go below 10%, perhaps. So if you're the type of person, you get at 10%, it doesn't shut down, then you're going to have problems. But it's up to you. If you have enough power, set up to 20%. Again, if for some reason it shuts down below 10% or at 10, you want your system to give it time to charge up again before you put a heavy load on it. And 20% is a good figure. And things will usually go back to normal, especially if you have a system, just like on the lead acid side, that can handle both the loads and the charging. This particular unit can go up to 120 amps. However, the BMS will control the amount of current. With the Sunfun kit, it's around 60 or 70 amps with this one battery. However, if you have 3 or 4 of these batteries, then you definitely will need 120 to provide the 50, 60 amps for each battery, or it will share it across. Okay, the other one, do not restart after short circuit. Okay, this is something you should do not proceed. In fact, it's such a serious issue that you need a password to access it or create one. It's only required in Germany, and it's usually you're connected to the grid system. With an RV scenario, off-grid, things of the sort, let's leave it unchecked. Enable, I think this is the automatic energy savings. I'm using the VE bus system, so it's not required. If it was enabled, the inverter power consumption is reduced by about 20%. So you're going to use less battery power if you're off-grid. It will switch back to normal. Okay, let me just close this off. Getting windows opening up here. Okay. It will switch back to normal when it detects a load. However, there will be a slight delay, usually less than 1 second. Again, depending on the modifying option that you use. Let me show you here by enabling it. Okay, this will usually require less than a second. If you go into a search mode, it will require at least a second for it to recognize the load. So if it's something that you're going to turn on and it demands it so much that it trips a breaker or things of that sort, you're better off to turn it off. And these are the watts that you can set. The total 16 and 14 is what it's going to use to determine when to cut back and to switch to energy saving, and when it should cut back again. So that's basically how it works. In my case, I think most people's cases, you don't need it. Okay, for charger, I'm going to deal about that in another video. A lot of important things in here. And the virtual switch and the assistance, if I turn this on, for example, then I have the option to add assistance. This is where I can use the relays to turn things on and off. If you have a system where you have an AC2, for example, you can set it up using these assistants. So let's say your state of charge of your battery system, you have a big one, 80%, 90%. If it sees that it's 90%, it will energize that second outlet, perhaps powering a heater. And you add a second assist where you say, if the state of charge drops to 50%, shut it down. So you might be able to use during the day your heaters, because you're probably bringing in 3,000 watts. And it's probably only at nighttime that this becomes more critical. So you may save on propane if you have an electric heater, depending on what your setup. That's something that I would deal a little bit more. For most people, the general, the grid, the inverter, and I think the charger, which I will talk about on another video. Let me know if this is something of interest to you. The concepts of this is generally true with almost any inverter. It may have a different layout, but the concepts are there. Some features may not be there. Some may have even extra features. Understanding this could save you lots of money and also save yourself from getting executed. Hopefully not. If not, at least a bad burn, especially when you're running 48 volts or more. Okay. Again, please subscribe. Thumbs up. Otherwise, YouTube will keep diminishing me in my stats. Take care. All these changes, you want to save it. You can save it and rename your text, or save the file that you just opened with. In my case, just hitting this. Would you like to save? And I say yes. And there you go. If I go back to downloads here, there's my savings right there. Yeah, I have that turned on. That's why it's saved for now. So this way I won't get bothered by that. And as you can see, everything the way I set up is saved. And all I do is I go to VRM online and upload this file. And I can do this not only on Windows, but I can do it on my iPad, because I saved the config file on my cloud or on my files and on my device, such as iPhone, iPad, or the laptop. All you need is internet. Both scenarios require internet, so you don't need the MK3. And I'm hoping that that will get dumped, and all the features that you need to change can be readily available on either VRM or Victron Connect app. That'll be another part. Take care. Sorry for saying it twice.